So last class we discussed some important topics, right? What were they? So I told you there were two important concepts I was discussing in previous class and asked you to revise them. What were the last two topics we discussed? Equipotential surface and the relation between electrostatic potential and electric field. So what is the relation between them? E is equal to minus dV divided by dl. Right? I told you we are going to do some problems based on them. Right. So mark this 2.3 as very important one. Guys, those who are online, am I audible?
Yes, sir.
Okay. So mark this 2.3 as an important one. Okay. So if you see in figure 2.8, A and B, there are some field lines that are shown with respect to positive and negative charges. Right. So our job is to give the sign of the potential difference Vp minus Vq, Vb minus Va. Secondly, we need to give the sign of the potential energy difference of small negative charge between points Q and P and A and B. Third is about work done. Fourth is about the work done by external agency. And the fifth one is about kinetic energy. So we go one by one. Okay. So how to start? So if I see point P and Q, I know this relation E is equal to minus dV divided by dl. So E is equal to minus dV divided by dl, right? Now, when I take this into consideration, listen. We know that the negative sign indicates that the electric field is in the direction of, what did I tell you last statement? Electric field is in the direction of decreasing potential. Is that right? So when that is going to be the scenario, then what can I say about Vp minus Vq? So look at the direction of electric field due to the positive charge. I hope you guys have textbook, right? So go to page number, what is it? 59. In that you have example 2.3. Observe the direction of electric field between the points P and Q. It is going from P towards Q. So what will be the direction of electric field? It is from the higher to lower potential. That is the meaning of direction of electric field is in decreasing potential. So Vp is greater than Vq, accepted? Yes or no? Then what about Vp minus Vq? So it is greater than 0. That's what they say. Give the signs of the potential difference, Vp minus Vq. Then what about Vp minus Va? What about Vp minus Va? Check, no. See, it is very simple again. There is point A here, point B here, right? A is here, B is here. What is the direction of electric field from B to A? So, which one is greater? Vb is greater than Va. Then what can you say about the difference between them? Positive. So, what is the conclusion that we can write? In both the scenarios, it is going to be positive. And what will be the reason you will write? What will be the reason you will write in the exam? Since electric field is in the direction of decreasing potential, it is evident from the diagram that potential at point P is greater than the potential at point Q. So Vp minus Vq is greater than 0. It's positive. Similar is the case with respect to Vb minus Va. Is everyone clear with this? Yes? This is a very, very important condition. Okay. Next. Now, read the second question carefully. Okay, don't be in a hurry. Read it carefully and tell me how are we supposed to solve this. Give the sign of the potential energy difference, right, between which two points, between the points Q and P and A and B. Read the points carefully, right? So give the sign of the potential energy difference when you move a small negative charge between the points Q and P. So where is the negative charge moved from? Initially, you have negative charge, which is at point Q, and you're moving it to point P. So they're asking, what is UB, sorry, tell me. They're asking what is UQ minus UP, accepted. So that is the meaning of potential energy difference. So UQ, can I write it as the charge that you're trying to move into VQ minus VP, accepted. Why did I write it like this? What is the relation between potential energy, charge, and potential? So U is equal to Q into V. Is that right? Check your notes once. So U is equal to Q into V. So in both the cases, the same charge is moved between the points P and Q. Correct? So I need to make a small change in my expression. Correct it. I wrote Q into VQ minus VP, right? Read the question carefully and make the correction. Minus. Is that what you're saying? Be confident. That's right. Why minus? Because you're moving the negative charge. I told you when you're dealing with scalar quantities, what are we supposed to do? Take the sign of the charge into consideration. So minus Q into VQ minus VP. But tell me what is VQ minus VP? We need not calculate the values. The previous question, you calculated VP minus VQ, right? What is VP minus VQ? Positive. Then what will VQ minus VP be? Negative. So negative multiplied with negative is going to give you a positive value. Are you able to understand? So UQ minus UP is positive. Now I'm giving you 2 minutes time. Find out what is UA minus UB and tell me. Sanjeevan. A and B. So find out UA minus UB and tell me. What is the answer? How? You're able to see? Okay. So minus Q into VA minus VB. But what is VA minus VB? Negative. So negative into negative is going to give you positive. Right? So this is also positive. What about C? Give the sign of work done by field. Okay? Give the sign of work done by field in moving a small positive charge from point Q to P. So you have to think in terms of the basic definition of work done. Why negative? So read the question. Give the sign of the work done by whom? Work done by whom? Work done, I always told you should ask the question, which force is doing the work? Third question. Work done by the field means work done by the system itself. So give the sign of the work done by the field in moving a small positive charge from Q to P. Okay. Now observe, what is the direction of electric field in the first case? It is in this way. Accepted. What is the direction of motion of charge from Q to P? So what can you say is the angle between force and displacement? So is it going to be negative or positive? That's the answer. Okay. Don't read the solution that they have given. It might confuse you. Okay, I'm trying to speak in terms of angles. See, from the beginning, I'm trying to give you different explanation. For the first one, I told you that the direction of electric field is in the decreasing potential. Secondly, you understood what formula applied, Q into VA minus VP. That is the formula we applied, and we tried to take negative into negative. That is where we got positive. Third case, what are we trying to say? So in the third case, what are we trying to say? Work done, right? You're trying to take the angle between the particular force and the displacement, and it comes out to be negative. Right? What about the answer for the fourth one? Use the same logic. D. Give the sign of work done by external agency in moving a small negative charge from where to where? From point B to A. How is it positive? See, listen. This is the direction of electric field. Correct? Right. What is the displacement they told? They want the charge to be moved from B to A. So you have a negative charge moving from B to A. What is it? So that work done by whom? Work done by external agent. Work done by the field itself. Is it going to be positive or negative? Work done by the electric field. Is it going to be positive or negative? So if I take the external field is in this direction. Now the question is, the angle between external field and charge is how much? 180 degrees. Right. So is it going to be negative in this case? I want you all to think. Open your brain. Start thinking. Field is towards the negative charge, correct? Because negative charge will receive the field. Where is the external negative charge moved from? B to A means it is moved in the direction of electric field, right? Will that be possible? Will electric field be able to carry negative charge towards itself? It will repel, right? So who can move the charge from B to A easily? So work done by the external force will be C. I'm trying to give you a logic. Listen. Electric field is there, right? If you are moving a positive charge Q from B to A, the work done would have been positive. Why? Because you're talking about attraction. Attraction happens naturally. Whereas, if this is the direction of electric field, if you read the question, what are they trying to say? Work done by the external force. So external force will exactly be in the direction opposite to the electric field. Are you guys able to understand this point or not? So had it been a positive, listen to my statement carefully. Had it been a positive charge and you're trying to move the charge from point B to point A, then the work done by the field would have been positive and the work done by the external agent would have been negative. But here, what is the type of charge you're trying to move? Negative. So the scenario will get completely reversed. Why? Because negative sign is there. No. So if you see that negative sign when you're trying to move it from B to A, will the electric field be able to support it or oppose it is what my question is. It will oppose. No. So work done by the electric field in this scenario will be negative because of the negative charge. Try to understand. So what will be the value due to the external force? It will be exactly the opposite. That will be positive. So what I'm trying to tell here is, if you read the difference between previous question and this one, in the previous question, read it carefully. Work done by field in doing what? Positive charge from where to where? In the positive charge, so a small positive charge is moved from Q to P, means you're moving in the direction against the electric field. That is why it became negative. Okay. So that is the work done by the electric field. Whereas in this case, there are two changes that are happening. What are they? One is positive charge is converted to negative charge, and the second is electric field is replaced with external force. Right? If you revisit the definition of electrostatic potential energy, revisit the definition again. What did we say? It is the amount of work done. Right? It is the amount of work done to do what? It is the amount of work done by whom? External agency. Be clear with that. By an external agency to do what? To move the charge from infinity to some point within the electrostatic field. If you see the work done by external agency, there would have been negative. Right? The final answer comes out as negative value only. No, minus k q1 q2 divided by r. Right? So you need to have a clarity. So what I'm trying to tell you here is, whenever you are asked to calculate energy, right, you generally don't take the sign into consideration. Listen to my statement carefully. Second question is what? It is energy difference. Okay. Generally, there will be some questions where they will ask you to calculate energy. Generally, energy doesn't have any sign, whereas work done has sign. Similarly, energy difference has sign. What is the meaning of it? Energy difference has sign. Right, they ask you only energy, right? Generally, when you calculate energy, energy is neither positive. Energy has no sign in the first place. You cannot say there is positive energy or negative energy. Nothing like that. You will only say positive work is done, negative work is done, or zero work is done. But try to understand, whenever work is being done, it will get stored in some form of energy, and by default, that energy is written as positive value only. Okay, but what happened is the second question. They didn't ask you the energy directly. They asked you energy difference, means both the energies, if they take it as positive also, the difference between them could have been positive or negative, because one could have been greater than the other. That is why in this case, sign is taken into consideration generally. Are you able to understand? Similarly, when they ask you about work done, the best way to solve any problem based on work done is first identify the force and give a direction to it. Secondly, observe the direction of displacement. What did I tell you? First is observe the force due to which they are asking us to calculate the work done. Then assign a direction to it. Then secondly, take the direction of displacement. See the angle between them. If the angle between them is 0, it is positive. If it is 180, it is going to be negative. If it is perpendicular, it is going to be 0. Okay, that is how all the questions are framed. I'm reiterating on this because this kind of question comes in your boards. I've seen people struggling. You should have clarity on it. Is that clear? And the last one. Does the kinetic energy of a small negative charge increase or decrease when it goes from point B to A? How did you say? That's right. Okay, that is one way. And one more point I wanted to mention is there is something called as work energy theorem. You know this, right? Work done by all the forces is equal to change in kinetic energy. So if you see, does the kinetic energy of a small negative charge increase or decrease when it is moved from point B to point A, right? So what is the work done? What is the work done by the external agent? Sorry, what is the work done by the field? Does the kinetic energy of small and negative charge increase or decrease when it is going from point A to point B? So, sorry, point B to point A. So what is the work done by the electric field? It is negative. So negative is equal to delta K, implies what? Final value is lesser than the initial value. This is another way of giving an explanation. So whichever is comfortable for you in this scenario, you can take it. So for this one alone, you can, if you want, you can take the explanation from the textbook or the one which I gave you, whichever you have understood. Is that clear? But I'm more concerned about work done. Since the potential energy Is it increasing? UA minus UB, is it positive? You can say that because the total energy is conserved. That is also there. Okay. So as I told you, mark it as important, practice it again. Okay. So with this, we have completed a problem based on the relation between electric field and potential gradient as well. Now we'll go to example 2.4. Read the question carefully and write. There are 4 charges which are arranged at the corners of the square ABCD of side D. Okay. Find the work required to put this kind of an arrangement. You see here, what have they asked? So what have they asked? Find the work required to put together this kind of an arrangement. So look at the arrangement carefully. Okay. Secondly, they told there is a charge Q naught which is brought to the center E of the square. The 4 charges being held fixed at its corners. How much extra work is needed in this scenario? I want you to think and do it. Don't read the solution, you guys start thinking. So what are they trying to say? So initially, where were the 4 charges? So what is the meaning of the statement? Find the work required to put together this kind of an arrangement. What is the meaning of it? Initially, where were the 4 charges? They were at infinity, in the sense they were not interacting among each other. They didn't have any connection with each other. Now, what happened when they were at infinity? Who needs to do work to bring this kind of an arrangement? External. So you take 2 charges, just try to bring them closer and try to take the next 2 charges and bring them closer so that it forms a square. So they are asking, by doing this kind of work, how much energy are you generating? So if you're able to calculate the total energy also, you'll get the answer. So calculate the total energy of the system. What energy will you calculate? Potential or kinetic? Huh? Calculate the electrostatic potential energy, you will get the answer. Do it. Don't read the solution. I'm repeating it again. If you read, you're not going to understand. So how will you start writing the answer in exam? The total work done on the system will be equal to the potential energy stored in the system. Or you can say the total potential energy stored in the system. Work done on the system is equal to the total potential energy stored in the system. Right? What is the formula for potential energy? Minus K Q1 Q2 divided by R. Right? That is for the point charge, right? Now see here the technique is, how many charges are there? 4, right? So how many expressions, how many terms will be there in the expression? Yeah, 3. Okay. But the question is, when you're writing the formula for potential energy, always, I'm going mathematically, okay? What are the minimum number of charges that are required for you to write the expression for potential energy? Minimum or 2, right? So how much you have? You have 4, right? So can I write, what did I tell you? The total potential energy is what you need to calculate. Can I say, this total potential energy is sum of the potential energy that is existing between the points A and B, accepted, plus the potential energy that is existing between the points B and C, yes, plus the potential energy that is existing between the points C and D plus the potential energy that is existing between the points D and A. How many terms are there? 4. But is it all? That's what I was about to ask. Is it all? No. Because you have other two combinations also. What are they? Now you took all those things along sides. You have along the diagonals as well. That is UAC plus UBD. So for all these things, you need to calculate the distances and write the correct value. Now tell me one thing. Out of these, 4 values will be the same. What are they? AB, BC, CD, DA. Why? Because same combination of charges and same distance of separation, right? So can I write 4 times UAB plus what about UAC and UBD? They are equal because in one set you have both positive charges, in the other set you have both negative charges, right? So plus 2 times, can I write UAC? Is it simplified? Right? So 4 times, what is UAB, guys? Minus K Q into minus Q up divided by the distance of separation between them plus 2 into minus K into Q into Q divided by root 2D. Accepted? Yes. Why did I write root 2D? Because it's the length of diagonal. So I have K Q square divided by D taken out. Right? So what is left out here? I have a 4 left out here minus this will cancel this root 2 times. So this is going to be the final expression for the total potential energy, and that is what they indirectly ask you in terms of work done. So in this case, work done means work done by whom? Work done by the external force, and that is what is getting stored as this total potential energy. Am I clear with this? Right? 4 minus root 2 that into KQ square divided by D. Did I miss the minus sign? So why are they getting the work done depends on the arrangement. Yeah. So KQ square divided by D into 4 minus 2. Right. Clear? Now, what is the extra work that you need to do to bring the Q naught from infinity to the center of the square? That is the point of intersection of diagonals. So how to calculate? UAB. Okay, if you do that, what do you think you will get? Okay, I'll give you a hint. Listen. There are 2 types of questions that they will ask you, which are based on potential energy and potential or work done. Okay. So I hope everybody understood the first question, right? No doubt in that. Okay. Next time, this is how you do it. Secondly, when they ask you how much is the extra work that is needed, right? And they give you the charge that they're trying to move, what you do is calculate the potential of the system and multiply it with whatever charge you're trying to move. So these are the steps to be followed. So write down steps to be followed to calculate extra work done on moving a charge. Steps to be followed to calculate extra work done. Underline that word, extra work done. To move a charge, extra work done to move a charge, say Q naught. To move a charge, say Q naught. Put that Q naught in inverted comma. Are you able to understand what I'm trying to say? So what are the steps to be followed? First, calculate the total potential. Calculate the total potential at the point. Calculate the total potential. Small correction. Total potential between the points. So between the points where the charge is moved. Okay. Second step, multiply the charge with potential difference between those 2 points. Multiply the charge with the potential difference between those 2 points. What do I mean by those 2 points? Between the points where the charge is moved. You're able to understand? So in this scenario, where is Q naught moved from? So Q naught was initially at infinity. So what is the potential at infinity generally? 0. So it is moved to point T. If you're able to calculate the potential of point T, how much is it going to be? It is potential of A plus B plus C plus D. Right? Unlike previous scenario, I didn't write A, B, B, C. Why? Because potential energy is calculated between points and potential is calculated at a point. Right? So out of all this, which one will have equal values? So VA is positive, VAC is positive. So can I write this as a combination of VA plus VC plus VB plus VD? So VA plus VC will give you a positive value and VB plus VD will give you a negative value. Both are of equal magnitude but opposite in sign. So the total potential at point E will be 0. So initially the point where it was present had 0 potential. Final point had 0 potential. Now you are moving the Q naught between those 2 points according to the steps that you are supposed to follow. Answer is work done is Q naught multiplied with the potential difference between those 2 points, V infinity or VE minus V infinity. What is the answer? 0 minus 0. Answer is 0. So that tells you that you need not do any extra work to move the charge from infinity to that point in whichever path you want because the forces are conservative in nature. Am I clear? Guys, these are all very important problems. Am I clear? Yes? Whatever. This is the thing that VE is 0, V infinity is 0. So work done is equal to Q into VE minus V infinity. Answer will be 0. So that tells you that you need not do any extra work to move the charge from infinity to point D. That is the meaning, right? See the exercise. Okay. So I hope it is clear, right? So last but one concept that is from the first part of this chapter is potential energy of a dipole in an external field. Right? Write down the heading as potential energy of a dipole in an external field. So there was a similar concept in the previous chapter. What was it? There was a similar concept in the previous chapter. What was it? Electric field and in external field, when they're saying what was there, what did we calculate? You calculated the torque. When you place the dipole in external uniform electric field, it experienced torque. You remember P vector cross E vector, right? So in this chapter, what you are calculating is when you place the same dipole in an external uniform electric field, how is it going to have the energy stored in it? That's what the question is, okay? If you see the diagram, again, it is same. So you have set of parallel lines. Means what are they? It is uniform electric field. In that uniform electric field, you are placing the charge. So you are placing dipole plus Q and minus Q, right? Making the axis of the dipole is making an angle theta with respect to the x-axis. Sorry, with respect to the electric field, right? Now, what will happen to this dipole as soon as you place it in external electric field? It starts experiencing torque. And what is the value of torque it is going to experience? So torque it is going to experience is PE sin theta, accepted, right? Now, due to this torque, what will happen to the system? It starts revolving, accepted. So is the direction which I assume correct? This is the direction of QE and this is the direction of minus QE. Negative charge experiences force in the opposite direction of electric field. So it starts revolving in the clockwise direction, right? Again, what is the topic? You need to calculate potential energy, but there is no direct formula for energy. Energy is always calculated through, I've also told this many times. What does all the definitions start with? Somebody is telling, be confident. It is work done, right? You need to calculate the work done by the torque, right? So work done, I think I've already given you formula. What are they? Work done is equal to force into displacement into cos theta, or work done is equal to integral of FDS. This we have seen many times, right? But unfortunately, in this case, there is no force acting. Rather, it is torque that is acting. So what should I replace force with? So dW, I will write it as torque that is acting on the system multiplied with the small amount of angular displacement that takes place. That is d theta, not theta. Are you able to understand? So this theta and this theta are not the same actually. Try to understand. So dW is equal to tau d theta. So work done will be equal to integral of what is the value of torque acting on the system? PE sin theta. I'll not take P cross here. I'll take it as P sin theta because I need only magnitude. P sin theta multiplied with d theta when the system is revolved from initial angle theta 1 to final angle theta 2. Okay. So if I calculate the work done will be equal to PE into integral of sin theta d theta from theta 1 to theta 2. Accepted. So what is the integral of sin theta? Minus cos theta. Calculate the value and tell me. Okay. PE into, you will get minus PE into cos theta 2 minus cos theta 1. Because integral of sin theta is minus cos theta. So take that minus outside. Upper limit is cos theta 2. Lower limit you apply, you get cos theta 1. Am I clear with this? Is there anyone having doubt on this? Yeah, tell me. Which one? See, work done is equal to integral of tau d theta. 1 minute, I will come to that point. P sin theta d theta from theta 1 to theta 2. So if I take the P outside, integral of sin theta from theta 1 to theta 2, this will be PE into minus cos theta from theta 1 to theta 2. Okay, I take that minus sign outside, I write it as minus PE into cos theta from theta 1 to theta 2. This is an extra step, that's it. So this will be equal to minus PE into cos theta 2 minus cos theta 1. This is the final expression. So if I have to write it in simple terms, it is written as minus P vector dot E vector. So this is the amount of work done, and this is what gets stored as potential energy due to a dipole when it is placed in external electric field. Is it clear? Initially from theta 1 to theta 2, and it moves from one angle to another. That's it. Right? Is it clear? Now see. We'll do a problem based on it. Read the question carefully. The question is very big, but the answer is very small. Which angle is it? D theta 1. Initially, it is theta. Okay. D theta is the small amount of variation that is happening. Sin theta, that theta is different. That theta is the actual angle made. D theta is the small angle through which it has. Okay. So, okay. Yeah. Because you'll start differentiating. That's why I told don't do it. Okay. So, read the question carefully. There is a molecule of a substance that has a permanent electric dipole moment, and its magnitude is 10 power minus 29 coulomb meter. Okay. First, make a note of it. So, first collect the data. Don't read the question completely. So, there is a molecule and it has a dipole moment. So, what is given? P 10 power minus 29 coulomb meter. There is a mole of this substance. As soon as you see mole, what are the number of particles that come to your mind? 6.023 into 10 power 23. Okay. So these are the number of particles that are present. Okay. A mole of the substance is polarized at low temperature. We need not worry about what is polarized. Okay. By applying a strong electrostatic field of magnitude 10 power 6 volt per meter. So what is required from this data? We need only the value of electric field. Write it down. So electric field is how much? 10 power 6 volt per meter. Why is it volt per meter? Now you would have understood, because in the previous chapter I told you, right? E is equal to F by Q, guys. So Newton per coulomb. But in this chapter, E is equal to minus dV by dr, volt per meter. So that is why you have 2 units. Okay. So what are they trying to say? There is a mole of the substance, and polarized in the sense it is kept in the presence of electric field by a magnitude of 10 power 6 volt per meter. The direction of field is suddenly changed by an angle of 60 degrees. Right? It is changed by an angle of 60 degrees. Estimate the heat released by the substance in aligning its dipoles along the new direction of the field. For simplicity, assume 100% polarization of the sample. Okay. So let's not worry about polarization in this problem. So they are asking, estimate the heat released. What is the meaning of this? Why is there heat getting released in the first place? Because there is some work being done on the dipole due to the electric field. So when this is happening, it is going to release heat. And that's what they're asking. So indirectly, what are you supposed to calculate? Calculate the energy of the system. You have all the data that is required. Question is big, but answer is one step. So you have dipole moment, you have electric field, and you have the angle. Just apply the formula, you'll get the answer. So only thing is, you should not directly take the dipole moment. Why? They gave you the dipole moment. Now, how much is it? 10 power minus 29 coulomb meter. That is the dipole moment existing between one molecule. But how many molecules are there? 6.023 into 10 power 23. Means those many number of molecules has to get multiplied with the dipole moment, because those many dipole moments are going to come into picture. Right? So the total dipole moment will be equal to 6.023 into 10 power 23 multiplied with each dipole moment across the molecule, that is 10 power minus 29. So this comes out to be 0.0 sorry, 6.023 into 10 power minus 6 coulomb meter. This is the total amount of dipole moment. And this one is placed in a system of how much value of electric field? 10 to the power 6 volt per meter. So E value is there, P value is there, and theta value is there. Calculate and tell me the answer. So the amount of heat that is released is 3.01. Okay. But if you see the question, if you read the question carefully, the direction of the field is suddenly changed by an angle of 60 degrees. So what is happening here is the dipole is not rotating. The field direction itself is changed. Means initially, what can you assume the field direction to be? Initially, you can assume it to be 0. And finally, it is 60. So here, you're going to calculate the change in potential energy. How much is it? So that is the potential energy. It is coming out to be minus PE into cos theta 2 minus cos theta 1. Guys, are you able to analyze the question? You can do it next time, right? So P you have, E you have. What is theta 2? Theta 2 is final value, that is 60. Initially, it was 0. Apply that, you will get the answer. So you cannot ignore 0 because cos 0 is a non-negative value. It is 1. And yet the potential energy of the system is positive. That's it. Okay. Is it clear? Okay. Now let's try example 2.5. Try this question on by yourself. So 2.5 also speaks about the electrostatic potential energy of the system. So there are two charges. What are they? 7 microcoulomb and minus 2 microcoulomb. And there is no external electric field present. Okay. Why did they mention it? Why did they mention this point? So read the question. Determine the electrostatic potential energy of a system consisting of two charges, 7 microcoulomb and minus 2 microcoulomb with no external field. Why? Because if you have new external field, then the potential energy due to that field will also get added. Just now we saw a minus PE cos theta. That will also get added. So what they want is purely the potential energy that is existing only due to these two charges. Okay. Secondly, they are placed at these vertices. What are they? One is minus 9, 0, 0. That is on the negative x-axis and 9, 0, 0 on the positive x-axis. So calculate the value and tell me. So potential energy between the point AB, how much is it? Minus K Q1 Q2 divided by R. Minus K into Q1 is 7. This is minus 2 into 10 power minus 12. The whole divided by, what is the distance of separation between them? It is 18 centimeters. So 18 into 10 power minus 2. So when you calculate this, how much are you getting? 7 or? 7 is what? So this one comes out to be 9 into 10 power 9 into 7 into 2 into 10 power minus 12 divided by 18 into 10 power minus 2. So this goes 2 times, this goes 2 times. So this becomes 10 power minus 3 into 10 minus 2. Sorry, plus 2. So 7 into, that is 0.7 joules. Is that the answer? So 0.7 joule is going to be the answer. Okay, next. How much work is required to separate the two charges infinitely away from each other? What is the meaning of this? Read the question carefully, you will get the answer. So what are they asking? How much work is required to take these charges and separate them to infinite distance? So initially, how did the system get formed? Both were at infinity and you brought them close to each other. You did some work and that work got stored as potential energy of how much value? 0.7 joule. So you need to do the same 0.7 joule of work to break the system. So whatever is the energy present in the system, you need to supply the same amount of energy to break it. Because they didn't take the minus sign. They took the so they took it as 1 by 4 pi epsilon naught into Q1, Q2 divided by R and then did it. Okay. Then in the place of Q2, there they substituted negative sign. We substituted, but we took the formula itself as minus KQ1, Q2. So we started the formula itself with minus because we are assuming that this potential energy is due to the work done by the external force. Right. Next, if you read the third question, suppose that the same system of charges is now placed in an external electric field. So initially it was not placed. Now it is placed in an external electric field where E is equal to A into 1 by R square. A is what? A is not the area, guys. A is some constant whose value is 9 into 10 power 5 coulomb per meter square. What would be the electrostatic energy of the configuration? So what would be the electrostatic energy of the configuration? That's what they're asking. Suppose the same system of charges now placed in external electric field whose values are given by this parameter. So E is equal to A into 1 by R square. Okay. Now your job is to find the electrostatic potential energy of the configuration. How do you do that? So electrostatic potential energy, can I say Q1 into, see there are two places at which the charges are present. So one is at minus 9, 0, 0, and the other one is placed at 9, 0, 0. This is point A, this is point B, this is 0, 0, 0. Accepted? Right. So how much is the charge present here? 7. So 7 microcoulomb is placed here, minus 2 microcoulomb is placed here. Now what you need to do is you need to calculate the potential at point A and the potential at point B and multiply them with the respective charges at that point and add them. In the sense, you take this charge as Q1. Q1 should be multiplied with V1 and added to Q2 and V2. That will give you the answer. That is what they ask to calculate the total energy of the system, right? Okay. So if electric field is given, how will you calculate the work, the potential? So E is equal to A divided by R square. But what is E equal to? Minus dV by dr, right? So dV will be equal to minus A by R square into dr. Accepted? Now when you integrate on both the sides, you will get D is equal to A divided by R. Okay, next time onwards, you need not do these many steps. If electric field is inversely proportional to R square, then you can say that the potential is inversely proportional to R. Remember that. Okay. So Q1 is 7 into 10 power minus 6 multiplied with V1 is A by R, where in the place of R you will substitute 9, plus Q2 is minus 2 into 10 power minus 6 into A divided by R. That's the answer. Okay. A is some number, some constant. So this part is important. Now, are you guys clear with work done, energy, and potential problems to some extent? Right? Okay. So we'll stop with this concept. Tomorrow we'll discuss electrostatics of conductors. Okay. So this one, there are 6 properties. After that, we have capacitors. So with that, the chapter is over. So maximum 2 more classes is what I'm assuming. Let's see. Okay. So revise these concepts. Any other doubts? Clear? Yes? Okay. Guys, those who are online, any doubts? Guys, those who are online, any doubts?
No doubts.
Okay, then we can wind up.